Good morning, all. Thursday, October 7th, 2021, Maroon Day today. Chicken hot dish, chicken nuggets, hammy cheese, southwest salad, Spartan grill, cheesy pizza, steak, Thai, chicken pizza. Activities today at 1 o'clock. Cross country meet at the Bedward, the Lee Country Club. Future conferences tonight, 3:30 to 7:30. 5 o'clock this evening, dance at service. All students are welcome to Foreign Friday tomorrow. The Lightenberg Group. The topic is the color of our history. Game Club. All-day gaming events Saturday, including free Magic Tournament, console, tabletop, supersized D&D. Lunch is provided. Each doors will be open at 10:30 a.m. The event takes place in the library. Anime Club. Hosts watch parties every Monday during lunch. This is the Lightenberg Room. All anime fans are welcome to attend. Anxiety group meetings, if you're interested in that, stop in the guidance office. Begin Tuesday, October 12th during Spartan time in the classroom located up by the restroom room. Package additional information in the counseling office. Deadline to apply is tomorrow, Friday, October 8th. Sophomores, sign up for Hobie Youth Leadership Seminar. Takes place June 9th through 12th this summer at Dakota State University in Madison. You can stop by the counseling office for more information and sign up. Juniors and seniors, if you're interested in the military, and you visited with them yesterday, you must and are required to take the ASVAB test for military entrance. ASVAB test will be given the afternoon of October 12th, blocks 3 and 4. It is a career assessment tool that can help any student. Even if you're not interested in military, sign up, take the ASVAB test. It is free. Seniors, those who with 3.55 higher GPA received a email earlier this month from Mr. Lightenberg. If you're interested in applying for National Honor Society status, fill out the application. All please stand for the pledge. Please do the flag. United States of America. One nation, under God, indivisible, with liberty and justice for all. Final announcement, you usually see during Spartan time. You need to stay in your regular Spartan time class because she will not be available. Those students who use CCC stay in your regular Spartan time class today. All have a great day.
She's our ESL specialist. Looks like most of you done. Anyone still going? That don't count. That was a choice, bud. All right. Oh, before we get rolling, I don't know if I said this in here because I can't remember what class is what. I was wrong. It isn't an early release. I found that out like Monday. So, yeah. Now, most of you are out of Spartan time anyway, so it doesn't matter. You know, you still get to go. But I get to go from class to parents with a 15-minute break. It's a 13-hour crapathon today. So, I thought we had an early release because this is year 7 here for me. We've always had an early release for parent-teacher conferences. We have always had them. Yeah, we had early release. First semester we had virtual conferences, but it was still the same schedule. So, or second semester it was business as usual because South Dakota. So, stage 1, I have what is it called? What type of function is this? Not quadratic. It's in quadratic form. It is a polynomial. Can we go more specific? Like this is a thumb, not just a finger. Like we didn't specifically say it. I'm just wondering if you remember. Degree 2 is a quadratic. Degree 3 is a cubic. Degree 4 is a quartic. Okay. So, I have a quartic polynomial that is in quadratic form. If it's in quadratic form, that means I can factor it like a quadratic. It's going to be, instead of x's, x squareds. And I look for factors of -3 that add up to -2, getting -3, +1. Now from there, you can either keep going, because this is the difference of squares. This is the sum of squares. So you can either do that, use the sum and difference of squares, that form, or you could say x squared minus 3 is 0, like this. Okay, so either you factor using difference of squares, or you take them out to solve by square roots. In either case, I have x is plus or minus square root of 3 plus or minus I, because it does say to find all zeros. Possible number of real zeros, just by looking at it. How much? 4. Doesn't mean that it's going to have 4. It ended up only having 2. Possible turning points is always 1 less than that. So, I'm just going to say 1 for these combined, because that's just look at the degree, say the two numbers. I'm going to say, did you factor correctly? And whether you went difference of squares or solve by square root, you got some sort of work shown to say this is where it's going to go, and then the actual answers. Okay, so you factored, and then you either continued factoring or did square root. You got the right answers, you got the turning point and 0 thing. Any questions? Cool. Cool. You go away. I keep forgetting to bring up the book, but I don't think anyone in here asked a question either, and we had yesterday to just kind of fart around in class, so hopefully we asked then. Do we got something?
Yeah, number 27.
You got to tell me what it is. Okay, is it words?
No.
All right, then just tell me what it is here, and I'll. Yeah.
F of x is equal to x to the 6th minus 6x to the 3rd minus 16.
Okay, this is another one of those quadratic form ones, because I got a constant at the end, and the degree in the middle is half of the leading degree. So it's still quadratic form. If this was x squared and x, I would have just nicely said x minus 8 and x plus 2. But because it's x to the 6th and x to the 3rd, either this term itself or the square root of the leading term, either case it's x to the 3rd. You just cut that in half. Well, I got to keep going, right? So I'll set them equal to 0 and solve. So we have cube root of 8, which is 2, cube root of negative 2, which is just negative cube root of 2. There you go. Because it's an odd index, you do not need plus or minus. That's also why the sum and difference doesn't work. Specifically, the directions on this, did it say find all real zeros or all zeros?
All real zeros.
Okay. Then yeah, it's those two. Does anyone remember? Remember factoring or difference of cubes? Okay, we're going to hit it again. We're reviewing a lot of the polynomial stuff the next few days. But this is x minus 2 times x squared plus 2x plus 4. Yeah. And this is going to give you two imaginary zeros. So yeah, 2 is the real root of this. But that's actually a really common error. Algebra 2 and beyond is kids will forget that you can continue factoring this, and they'll miss the imaginary zeros. That's why I wanted to be sure about the wording on it. If they only want the real zeros, then cool. That's it, just those two. Okay, others? All right. Before we get rolling, a couple items. One, parent-teacher conferences tonight. The vast majority of you are doing stellar. Keep doing what you're doing. I make a point of telling parents, hey, PreCalc is past the high school curriculum. A C is expected, B is good, and A is outstanding. Okay? B in PreCalc is good. It might not be what you're used to. If your parents are pushing you to an unhealthy level of effort because they don't think that someone should have, oh my God, a 91, then tell them to lighten up. Are you doing your best? Could you move the needle by asking more questions? Could you pop in before class for 10 minutes and do a problem or two with me? Do you ask questions on Remind? Do you wander down during Spartan time to double check that thing that you got a 3 out of 5 on the daily quiz? That's it. Like, that's the difference between I got my 91 and I got my 94. Okay? That's literally the difference. And that's what I tell parents, and whether it happens or not depends on your relationship with your parents. So, otherwise, if y'all want to come down for conferences, I'm just going to brag you up and tell them to buy you something. So, wander on down. Like that's usually what I do. She's doing amazing. I don't have any problems. Like, buy her a puppy, please. Okay. So if you want a puppy, come to conferences with your folks. Next, we kind of talked about this yesterday. I double checked something. Remember, we were all kind of laughing at the freshmen. Every single one of those kids has 50% or more of their work missing. Every single one. So maybe it's not as dire as it looks. Those kids got a royal chewing yesterday. They got, it's myself and 2 special ed teachers in here. 3 special ed teachers for 16 kids. And they just refused to pick up the pencil. I've never seen that class like that. So, yeah, with the conferences rolling around, that'll be a fun night. Oh, I'm also going to sound gross because sinus infection happens every year within a week of conferences. Yeah. Now, I just, as a precaution, because I'm not a crap human being in South Dakota, I also got my COVID test yesterday to make sure. It is sinus infection. Sinus infections are not contagious. I'm miserable, not contagious. Okay? So, yeah. We did we do all of them? I thought we only did the top one. We did. Cool. That means we might be able to pop into 2-3 today. Score. Oh yeah, that's right, because the whole can you factor the big thing, right? We'll get more of that practice later. But we left off with I don't even think we got the first one done, did we?
Yeah, we were in the middle of it.
Oh, okay. So, f of x is x by 2x plus 3 by x minus 1 squared. So, then where we left off, we're talking about how the multiplicity of a 0 affects the behavior of the graph at that 0. So I know that I have zeros of 0, -3/2, and 1. But because there's a pair of 1s, I know that this is going to act like a line, this is going to act like a line, this is going to act like a parabola at those zeros. Then I use leading term test. Leading term test says, if I were to multiply together all of my leading terms, an x and a 2x and a pair of x's, I'm going to get 2x to the 4th and then a bunch of stuff. So my leading term is going to be a positive x to the 4th. If it's a positive even, we did do that last time, where does my graph start on the left side? Positive infinity. Where does it end on the right side? Also positive infinity. So I get this idea that I can shape the graph that we're going to hit -3/2, 0, and 1. It's going to hit this like a line, go to I don't know where. Hit this like a line, go to I don't know where. Bounce off of this and head back to infinity. I just don't know where these are. And that's where you grab the calculator and you find your extrema. Okay? Did we get to that point of actually labeling the extrema? Okay, so that's right where we're at. So, grab a calculatron and go to y is. You don't have to distribute the whole thing out. you can just type it as is. Say x by 2x plus 3 by x minus 1, the quantity squared. Okay, you can type it exactly as it says. And then I'm just going to go zoom standard because I'm not sure where the graph is going to land. Get back there. Okay. All right. Oh, here's another thing. I knew that this extrema was going to be further away from the x-axis than this one because the zeros were further apart. If the zeros are further apart, the extrema is further away. So like this guy, because they're only 1 unit apart, I knew it wasn't going to go too far. That's just a general behavior thing. Second, calculate. Find your minimum. Appears to be somewhere between -2 and 0. So your actual graph should look like that too. You should say -1, -4. You should have your zeros labeled as -3/2, 0, as 0, 0, as 1, 0. And then second, calculate my maximum between 0 and 1. And we'll label that point as well. Ooh, a point about this point. Say approximately. Now, this one's got a round off error, 0.375. We could write that as a fraction. Anyone know off the top of their head? 3/8. Yep. So that part is 3/8. I don't know off the top of my head what the other one is. You can try to find it by typing it on the main screen, change to fraction. But I was talking about what? Is it 511? I don't know. Well, someone do 0.5493164. Change fraction. If it does it, yay. If it doesn't, I'm okay with this. It is 6/11ths? Oh, okay. This is what I want for a full graph. Label the zeros and label the extrema. In this case, my y-intercept was also an x-intercept, so I didn't have to label them separately. Label your x's, label your y's, find the extrema in between. That's how you make a polynomial graph. Okay? So you should have all of that stuff. No, just graph. There we go. You should have all 5 of those points labeled when you make these graphs. The crinkle of the wrapper reminds me. I double-checked with Safeway, and we're going to keep the donut order going. Crinkle of wrapper, food. Food reminds me, oh hey, we're doing donuts tomorrow. So. Okay, this one's already broken up for you, so we'll start with that one. Okay, Graphify. Now, I also don't know where the extrema of this thing are. So, you might have to change the scale. I got a fuzzy memory in the back of my head that says one of these goes way off-road. If that's the case, change the scale of your graph to fit your extrema. Don't just BS it. Okay, start with your zeros and the behavior of the zeros. Your leading term tells you what your end behavior is going to be. You just have to find the extrema in between. Okay, if you get a goofy number, check with your neighbor. Make sure they're getting the same goofy number. Okay, I have a 0 that occurs once, means I got a line. A 0 that occurs 3 times means at that point, it's going to have that little kink to it, like a cubic. If I were to multiply together my leading terms, a negative 2x times an x times 3x's, like if I were to distribute the whole thing out, my leading term is going to be a negative 54x to the 5th. So that tells me my end behavior, it's going to start up at positive infinity, come down through 0 like a line, go up through 1/3 like a cubic, come back down through 4 like a line. Okay? And head down to negative infinity, because that's what a negative odd polynomial does. See how these two are super close together? I know that this is not going to dip down too far. These are further apart, so I know it's going to be much taller. And because I see x to the 5th, which gets really, really big, really, really fast, I'm betting this one doesn't just go off-road, it goes off-road a lot. 3,000. Okay. Up to 3,500. Wow. So I'm going to come over to my scale here, and I'm going to say go by 500s. Because I want to see my extrema. So I know I've got this point and this point and this point. What was that maximum at?
3,265.88.
Huh?
3,265.
So 3.25. There's 1, 2, 3, 4, 5, 6, 7 and change. Oh wait, no, not 7 and change, 6 and change. There we go. So I will label that extrema. Really, that's the one you're going to miss? Right about there. What about this guy? I'm betting it's not so extreme.
It's about
275? So almost right on the axis. Okay. And then connect the dots. Gonna come down through here, try to show the kink. Well, in the context of the graph. I'll let your freak flag fly, just not in class. Okay. But if you zoom in on this, like when it was a normal 10 by 10 grid, did you see it come down like this and then kind of have that kink to it? Maybe you have to zoom in more on it, but it looks like a cubic at 1/3. Okay. What if it is not done for you? What do you got to do first? Just factor it. Okay. So factor it and try again. Yism?
Still thinking, but
If the yellow circle of death in the corner ever turns white, you killed it. So we need to turn it off and on again, just like customer service tells us. Okay, factor it first, find your zeros. What does it behave like at those zeros? What's the leading term? How does that change your end behavior? Find the extrema in between. Also, I can't remember, was there anyone in here who was still missing a quiz? Okay. That's what I wanted to know, so I got it printed out and ready for Spartan time. Normally, I actually really like conferences because I'm a blabby person, so I just BS with parents. Yeah. This time, I'm, sinus infection. I'm miserable. I'd rather just go home and sleep.
Feel every day.
That's called depression, dude.
No, I got that fixed.
Okay. Today is Thursday. And you get a 3-day weekend. Yep. Not X squared.
and then we get a 4-day weekend and we have another 4 days. We don't have school the 22nd.
So there weren't repeated zeros. That means it's going to act like a line at each one of these and go through the x-axis. It's a negative odd, so I know it's going to start up here. Now it just looks like It's going to start up here at positive infinity. My infinity looked weird. I know it's going to come down through 0, through positive 4, through negative 2. And it's going to head down to negative infinity for end behavior. So I know it's going to go through here, through here, through here, like a line. I just don't know how far down here, up here, is this thing going. Okay? I just don't know. That's where you come in with your handy-dandy calculatron, and you tell me what those extrema are to the nearest thousandth. So, the minimum. Yeah, I never care what the directions say. We're always going 3 places. It's just experience has told me that that's accurate enough, but to the 10th or the 100th isn't. Where's this guy at? Minimum. $297. Big voices. You're on Price is Right. You're yelling at someone who's going to get you a treadmill. Come on.
Negative 1.296. Negative 5.01.
What? So what?
Negative 5.0.
0, 1.
49.
Okay.
Not everybody has that experience, Maggie.
And the maximum?
2.430. Oh, 16.90.
90 mutter. Oh. Okay. So if I know those, I mark -1 and change, -5 and change, 1, 2, 3, 4, 5, about there, and 2.43, 16.9 off-road. Do we want to go that far off-road, or should we go by 2s? 8. So there's 8. There we go. And connect the dots. But try not to suck. Mine got kind of pinched in the middle there. Okay. You have to know what the features are. Oh, I didn't label the features. Maybe I should label the features. Maybe I should say that that's at -2, 0. Maybe I should say that's at 0, 0. Maybe I should say that's at 4, 0. There we go. Now I got all 5 points on the graph. Hint, hint. All 5 points on the graph. Usually you have 6 questions on a quiz, 5 points each. Okay. Show me some thumbs. How you feel about the whole repeated 0 thing? Like, I know it's going to act like parabola here. It's going to bounce here, cubic there. Okay. Modeling with polynomials. This is where in Algebra 2, we show you linear regression. This is how you make a line of best fit. I say, why didn't you show us this in Algebra half? Because then you never would have done math again. You just let the calculator do it all for you. Then we do quadratic regression. Then we do polynomial regression, where you have to stick 3, 4, 5 different models on the same screen, and you have to determine which one is the best. So, create a scatter plot in the data, determine the type of polynomial that could be used to represent the data. It's less about can you do the math, it's more about can you press the buttons and interpret the math. What am I going to do with all that? Stat edit. Start typing. Ooh, these are all years. We don't want to say 1970, right? Because then our model is going to go all the way back to the year 0 as a y-intercept, and it'll say that the percent of your disposable income in the year 0 was 630,000%. So we need to change it, and you change it however you want. You can say X is years since 1970. So it'd be 0, 10, 20, 25, 30, 31, 32, 33, and so on. Or, Paul, you had said something with, if I call this 70, what do I need to state? X is what? Years since 1900. Okay, I like that one because you don't have to think as much. I like that. So I'll say X is years since 1900. Then I'll type in 70, 80, 90, 95, 100. What does it go? 101, 102, 103, 104, 105. 9.4 and then 10. Ah, crud. 9.4, 10, 7, 4.6, 2.3, 1.8, 2.4, 2.1, 2.4. Check me before I wreck me. Good? Okay. Pay attention to this again. The year, the percent of your disposable income that goes to your savings. So when they say 10% here, they're saying you paid your bills, average personal savings as a percent of disposable income. Okay, so you pay your bills, you got this much money left over. They threw 10% into savings. Okay? What does this mean? You're in debt. That's literally what it means. Like, you didn't have enough to pay your bills and then some. Like, legit, the average person did not have enough to pay their bills. Okay? Which is right. Like, nationwide, the average U.S. adult citizen has, what is it, like 15 or 20,000 in debt? So, yeah, it's bad. Create a scatter plot. You remember how?
Yeah, you go to second, y equals, and then go to
Second, right above y equals a stat plot. Make sure you turn plot 1 number on. Plot number 1 on. There you go, words. Make sure it's the right lists, because sometimes you want to have multiple lists compared. And graph. Oh, yeah, that's still there.
you have to, yeah, you have to put the other words.
Okay, but if I graph it, it's not going to show anything.
You have to figure this out.
Now that I've turned the stat plot on, I can do zoom stat. I want to make that really, really clear. If I plots 4 off, okay, if I zoom to my stats without a stat plot on, it won't do anything. But if the plot is on, now when I zoom to my stats, it goes right here. Okay. What does that look like? What type of function? Does it look like a line? Does it look like a parabola? Does it look like a cubic? Does it look like a quartic? You're going to have to find them all, and you got to determine which one's the best. Before I go finding all of those models, I also want to know what their correlation coefficient is, so I know how well they fit. Do we remember those? Who to what? The R-squared value, yes, the correlation coefficient. Now, when I go to calculate stuff right now, it's not going to show me that, because it defaults to having that off. If you're on a TI-84, you get to just go mode and turn your stat diagnostics on. If you're on a TI-84. Not everyone has a TI-84. They're expensive. I didn't have a graphing calculator until my second or third year of teaching. Okay. I did all of my math on one of those lame, like, $10 from 1992 calculators. Okay. Everything, including stats. I did it all with tables. Not because the technology wasn't there. I was just broke. Second, right above 0 is catalog. This is everything that the calculator can possibly do. I don't want to scroll all the way down to the D's, so right above my reciprocal button is D. And it'll get me to at least the D's where I can now turn my diagnostics on. Okay, that's what you got to do on the TI-83s, which is the emulator on your laptop that everyone has access to. Now that the diagnostics are on, stat, calculate. I'm going to have to do them all because I have to compare them. So, I'm going to start with linear regression. And I'm going to put that into Y1. Do we remember how we store them? Alpha, everything up here is shortcuts. Y equals is fraction stuff. Trace, alpha trace will bring up my shortcut menu. If I don't have the shortcut menu, I'm on a TI-83, then you're going to have to variables, the y's, the function, Y1. Okay? So I would like you to find the linear, quadratic, cubic, and quartic models. Write them all down and their correlation coefficients. 3 places. So, round 1. I got a linear function, negative 0.285x plus 31.160. R coefficient was 89.26%. It's always R squared. Okay. I got my line. 89% fit. Y'all don't want to see me walking around class with 85 or 89% of me covered. Okay? So, R squared. Yep. Now, undo it again. Stat, calculate, except now I'm going to find a quadratic model. I don't want to put that into Y1 because I already have a line in Y1. So I'll put it in Y2. Calculate. You see why we're using R squared? Because it doesn't even have regular R here. So now I have a quadratic at negative 0.0086 x squared plus 1.242 x minus 34.896. R coefficient of 96% fit. You know what? I'll even go further. We'll say 96.09. That's a lot better. And before I go finding the other two, I'm going to hit graph right now just so we can see those two compared to each other. Okay, you see how one has to just kind of try to thread the needle and the other one actually tries to hit all the points? I'm going to do it again for cubic and quartic. I have to compare all four of them together. So stat, calculate, cubic, putting in Y3. I'll tell you, this is a pain to do on a TI-83 because you don't have a color screen. So you just see a bunch of black and white pixels. And it can look kind of nasty and hard to tell what's what. So we got Y3, my cubic. What does that mean? Something e to the negative 4.
Really small.
Times 10 for that.
Okay, times 10 to the negative 4th. That's my scientific notation. So that's a point, 1, 2, 3 zeros, then 375, x cubed minus 0.108x squared plus 9.852x minus 281.612. Ew. But 97.11%. I just want to make sure I know. Nope. Okay. And then along comes cubic. Ooh. That looks pretty good. I just want to make sure I match my colors here. Okay, next one's green. Stat, calculate, quartic, Y4. Ooh, doggy. Y to the 4th is negative 0.12340 zeros, 174x to the 4th, plus 0.0065. I'm just trying to get significant numbers in there. 3 minus 0.9116x squared plus 56.401x minus 1284, Jesus, 84.45, with a correlation coefficient of 97.25. I need everyone to be here. This is just monkey button pushing, but I need everyone to get here before we can talk about what now. Because it did say to choose an appropriate model. Not necessarily.
But also, if you look at the graph,
That's why we have to talk about this. We know how to press buttons, but we have to talk about interpreting the math. In fact, that's what statistics usually is. It's not, can you do the math? The calculator's doing the math. You have to interpret it. 99% of all statistics are made up anyway. You have to figure out what it means. I also want to point out the law of diminishing returns. As I went from linear to quadratic to cubic to quartic, look at the percent fit. After a certain point, it's not going to matter that much. Also, look at what's happening to my opening coefficient. It's getting smaller and smaller and smaller, meaning it doesn't matter as much. So, when I graph, right now, I should think I'm going to choose the quartic, right? Because best fit. Cubic looks pretty good, but that quartic, oh, buddy, that's like almost perfect. And it's a better fit. But then we go back to the context of the problem. The year and the percent of your disposable income that goes into savings. This table only goes out to 2005. If I'm only looking between 1970 and 2005, I can use this data. I will use the Quartic because it's the best fit. That's called interpolation inside my data. I want to go past my data. Extrapolation. You did interpolation, extrapolation back last year, right? I hope. I'm going to take my window and I'm going to move it out. Probably important to go past the year 2008. Maybe let's go until you are out of college, maybe settling down, 26, another 10 years from now. What if I go down to 131? The year 2031, 10 years from now. Okay. I'm also going to expand my window out a little bit just because I want to see some stuff. Okay, now Claire, you specifically were saying we're going to do the Quartic. We're going to do the Quartic. We're going to do the Quartic. As soon as this popped on the screen, you said, cubic. Because if I trace, you see what I'm tracing right now? If I arrow up and down, I switch between things. Go to the line, and I'm going to say right now in the year 2021, the linear model says, y'all in debt, but it's not terrible. The quadratic says you're in debt and it's bad. The cubic says, oh, that's more in line with my table. The quartic, rut-row. Let's go out another 10 years. Let's trace out to 131. 10 years from now, y'all are out of college, maybe find that certain someone, you're looking at buying a house, all that kind of business. The linear graph says you do not have enough money to pay all of your bills. Look at the quartic or the quadratic. You're very in debt. The cubic gives you hope. And the quartic.
Did you just second trace?
No, I just hit trace.
And then typed in the number, right?
Okay, if I just hit trace and I try to hit a number right now, what is it on? What is it tracing? No, it's tracing my stat plot. So if it's not one of my data values, it's not going to be able to trace it. That's why I always arrow down onto the line and then start typing things. Okay. Let's say 10 years from now, okay, you got your kid. Let's go another 16 years from then when they are sitting in this room.
Oh god, that's so close. We're not gonna be doing the same math. I'm gonna be yelling at you.
Okay, what if I take that window, or you know what, not even the window. How about I go to my table where I can just start asking this stuff because it's going to have all of my functions on there. And I say, which one makes more sense? What happens in another 26 years when you're at 147 years after 1900? Now that the further you go out, the more you extrapolate, that quartic, even though it was the best fit, gets worse and worse and worse. This is after World War III. We are all living in an apocalyptic wasteland. Okay? Probably. 5 years ago, I used to make an awful lot of jokes about different things that are going to happen and saying raising a kid in that environment is criminal. Then we had kids, and now all of that stuff is coming true. So...
Well, don't say it's gonna happen.
Moral of the story, you know how to press the buttons. You have to interpret. Go back here. Read through the rest of the problem.
I don't have any space.
I have literally no.
You have to pick the polynomial that best models it. If I'm purely going off of the fit, my interpolation between 1970 and 2005, I'm going to use the Quartic because it fits the best in the data set. But if I am extrapolating, I don't want to use the Quartic because it gets real scary. It gets unreasonable. Use the model to estimate percent savings in 1993. What should I use? Okay, I'm going to use the Quartic because 1993 is between 1970 and 2005. It's interpolation. It's inside my data. So for this, I'm going to use my Quartic. But what if we had part E that said estimate in the year 2038? Well, now I probably don't want to use that Quartic. Okay. I've done these problems before where the line has this 80-something% fit, but because of how ridiculous the other ones got, we chose the line because it was the most reasonable. Okay. Oh, what's up, Andrew? You still with us? Okay.
Yeah, can we just do it?
Just once. Just one time.
I gave that to Brooke in Algebra 2, and she just straight up like executed Dawson. It's like poof right in the back of the head because he kept stealing her pencil. Like, y'all, it's not third grade anymore. Stop with the whole "I mean to you, so I like you" thing. Okay. All right. So let's answer the questions then. Create a scatter plot in the data. Determine the type of polynomial that could represent it. We found 4. Write a polynomial to model the data set. Which one are we going to choose as the best for our question? Well, for B, I pick a model, but I'm going to pick the model based on C is asking me to interpolate. I'll choose the Quartic. Okay. Then use the model to estimate in 1993. So I'll come back over here and say 93. You see, they were all relatively close because they're all inside the data set. So I will use my Quartic because it was the best fit inside the data set. In between 1970 and 2005, the Quartic had the best fit. So I'll use that one. What? No, ask it.
I thought it would have been the quadratic because it has higher.
Oh, you don't just pick what's better for you. You pick what the model is. Like, in between 1990 or 1970 and 2005, the Quartic fits the best. So use the Quartic to model your data. This is the answer. This is saying that we will save 5.5% of our income. Okay. And then use the model to determine. All right. This is one that you might not remember. I want to see who does. Use a model to determine the approximate year, the year in which the percent savings reach 6.5. Year. Is that X or Y? Okay, year is X, percent savings is Y. And try as I might, I have asked every teacher that I've ever encountered, high school or collegiate, why on earth does putting my dependent over to ask not work?
It's so annoying.
I can't put 6.5 in for y and it'll tell me the x that goes with it. It won't. I don't know why it won't.
Did it make a calculator that does?
Probably. I bet Casio's do for half the price. But TI owns the educational market, so that's what we're using. Instead, what I'm going to do, go back to y equals. We said that we were choosing the quartic, right? So I'm going to clear you out. Clear you out. Clear you out. We're going to keep the quartic. And now I'm going to say, when does the quartic hit 6.5%? Because now when I graph, I will see an intersection of graphs. When does this graph hit 6.5%? Well, second, calculate my intersection. It asks for first curve, make sure it's on the line. Second curve, make sure it's on the quartic. Hit enter, it'll ask for a guess. I don't care, tell me the answer. In the year 1990. Now, you can keep going. Take that decimal train times 365 days. Start subtracting 31, 28, 30, 31 until you get to what month and day it is.
Yeah, I'm gonna pass on that.
Or you could just say it's in 1990. Okay? Yes, because I showed going all the way down to the millisecond in class. So then he did that for every single problem we ever ran across like this. So,
I don't even know who that is.
the question is, can you do it start to finish on your own?
I don't.
That's with a lot of explanation. It doesn't take that long, I'll race you.
You're gonna win. You're smarter than me.
Where's a calculator that works? There we go.
I'm not saying I'm not smart. I'm just saying you're smart.
All right. Confirm. Calculator is blank. Okay.
I know, but
All right. Last time we chose what the x's were. Look at part A. Years since 1900. They are specifically telling us what to do. What's up?
I accidentally deleted list 1 and 2. How do I, like, the whole,
I have no idea, but Holden does. How did you get the list back after we deleted them? I always just reset the calculator. You found it the other day, like. Okay. All right, here we go. And no, you put in 0. Let L1, list 1, be the years since 1900. Okay. Go. Stat edit. 0, 30, 60, 90, 120, 180, 0.9, 26, 29.5, 33, 40.2, 42.7, 0.9, stat calculate, linear regression, stat calculate, quadratic regression, stat calculate, cubic regression, stat calculate, quartic regression, zoom 6, no, zoom 9. Come on, Frank, you're going too slow. Mini Frank. Cletus.
Cletus. Oh God, what is that?
All right, you're taking too long.
Right, but this thing, it wasn't.
Could we go years since 1900?
Years since 1900 says it in Part A. In 2005.
How do you get the store, like, to get, like, say I want?
Alpha Trace.
I did.
In 2005. Okay. Even with Frank Jr., Cletus over here, doing the wrong thing for a while on the spinning wheel of death, we got under 2 minutes. Done. Okay.
You're more educated.
I do it a lot. I'm saying it doesn't need to take a half hour.
Wait, we don't need to store it. I'm on the
Or, and we
cubic.
don't need to write it down, store it.
I think if we just
Okay. How about this? Look at the question. Estimate the median age of the population in 2005. Is that interpolation or extrapolation? 2005 is between 1900 and 2080. So if I'm going to be asking questions that is inside my data set, I'll just use whatever one has the best fit. So I'm betting it's going to be the Quartic, and make sure that you write down the correlation coefficient that goes with it.
I haven't even gotten cubic.
Okay. There. I'll do it again.
Yeah.
Second plus 7, enter 2.
So.
We have a 9.
Uh-uh-uh.
We're not getting an R factor.
You reset your calculator and it turned your diagnostics off. You got to turn them back on.
Then you turn it back on.
No.
Ask someone who is awake.
Oh.
Yeah. I don't know.
More school, less Rocket League.
You don't seem like a rocket player. I'm not. I'm more of a Minecraft guy myself.
Hop in our game club server. We got kids in there every night.
Wait, you guys have like a realm?
Yeah.
Yeah.
What? I feel like you guys are all just like, piss to each other's diamonds and stuff. No. We have rules. You can't say if someone blows up someone's house after you have to pay for it or we build it. Wait, are you in the round too?
He's well though.
I am not, because I gave up all consoles and video games 10 years ago. Because I fixate. On a normal night, 9 o'clock, I'm tired, I want to go to bed. Put a controller in my hands, it's 3 a.m. And then I kind of forget what day of the week it is and miss my wife's birthday.
Oh, that's what my dad did on our anniversary.
I knew what I was going to get her. I knew where it was. I knew how much it cost. I forgot that today was a Tuesday, because I was just sitting there playing God of War for like 6 days straight. So, yeah, I don't. Especially Minecraft, because that's like Lego video game, and that would be my heaven. And
Progressively just gets better and better.
no, I should not do that. I should really not do that. That's like you coming up to a 25-year AA recovering addict and being like, open wide, dude. Don't tempt me. Okay. I got a bunch of stuff. I also turned my diagnostics back on. It does not take long to do all the calculate regression stuff. Stat, calculate, linear regression, putting in Y1. Write stuff down. 97% fit is already pretty good. Stat, calculate a quadratic. Put that in Y2. 97.5, not much better, but better. Stat, calculate, get a cubic. Putting into Y3. 98.9, getting a little better. But look at what's happening to that opening coefficient, that leading coefficient. It's getting really tiny. We're getting into that law of diminishing returns here. Stat, calculate. Now let's find a quartic. (99.368% is really good. But look at the first two coefficients. They're both almost zero. So you get that law of diminishing returns. The difference between I got a nice suit that I tried on versus I spent $3,000 and had someone grope me so that it could be a little bit nicer. Tailors freak me out. Well, not these tailors, like the like no, just like someone touching you and the putting the tape measure like right up in there and just no. So I'm going to zoom. I'm going to zoom stat, and then my calculator. What did I forget? Okay, so second, stat plot. Turn the plot on. Now when I zoom to my stats, there's my stat plot. Line, quadratic, cubic. I said the problem wasn't, like, Frank is not a smart man. But Frank was being sabotaged by his ex. LMA over here was like poisoning him. So we sent her packing and we went and found his high school sweetheart. We brought back Bobby Sue. Our I had to get the old laptop because the new ones just, they suck. They can't run all of this at the same time. Okay, now, I want to point out something. If we're talking about in the year 2000, was it 5? 2005. I trace here. Wait a second. Do I do 2005?
No, you do 105.
Okay, because year since 1900. The line, the quadratic, the cubic, and the quartic are all fairly well in agreement. For all of the things that we're going to do here, I would use the quartic because it's the best fit. But according to your model, when was the median age? What? When was the median age 30? So I would y equals, come on, 30. There we go. So I can second calculate my intersection between, I wanted the quartic and 30. So I'll arrow down to shift to the quartic and 30. $1964. Do the math. That's when my mom was born. Okay.
My parents
Me too.
never thought that.
My mom just turned 57.
Me too.
Why are you in high school?
Because my mom is old.
Oh, I thought you meant, okay. Okay.
That's what I was like. I'm like, why?
So, now, if I'm interpolating, if I'm going from 1900 to 2080, I'm going to use the quartic. But she had me when she was 20. Like, she just turned 20 2 weeks before my birthday. She was a youngin'. And she had me, right? So, this right now, y'all, this goes to the year 2098. 77 years after now. Y'all will be old. Most of you will be dead. Okay? Okay. Hey, reel it back in. We're talking about the median age of the U.S. population. What happens when I take this out further? What if I go to 100 years from now? What if I go 121? Yeah, well, y'all be dead. I'd be dead. I'd be dead a long time before that. Okay? Oh wait, this only goes to now. Oops. I wanted 221. There we go.
I'll be dead, so I won't really. So I don't want it. If I make it past 60, that's probably why it looks
After 60,
I want you to pay attention to what's happening at the end of the graph. Do you see where, if I try to extrapolate further, the further that I go out, yes, the Quartic model fits perfectly for my data. But the median age of the United States population in another 120 some years is we all dead. Literally, World War III. Okay? So, what I need you to know is that when you do these problems, y'all, you have to be smarter than the calculator. Don't just press buttons, write thing down because that's what calculator told me. You have to interpret it in context of the problem. And the rule of thumb is that if it's interpolation, pick whatever has the best fit. If it's extrapolation, pick whatever makes the most sense. If I'm looking at this for what makes the most sense, short of a cataclysm, I would probably go with the quadratic instead. Okay? So, hi.
This could be a big question, but why do we only go to Quartic?
Why would you even go into
Look at the law of diminishing returns. Look at what your coefficients were.
Oh, so they
Once you start hitting Quartic, your A and B values were almost 0.
okay.
So it's just, after so long, it doesn't matter.
You just give up. It's all right.
Okay. I hope you can do it, because I guarantee there's one on your homework.
No.
There's an 83 emulator on the laptop. If you are not comfortable using the 83 emulator on the laptop, I highly recommend that you come down here during Spartan time so you can use the 84 and do it before you leave the building. Or, don't suck, have an Android and you get a free TI-84 on your phone. I'm not going to go into 2.3 yet, but before we head into 2.3, I want to see who remembers 3rd grade.
Oh no! These are so much fun.
Do it. No calculators. No calculators. Do it with that last got it slide under number 14. Who remembers elementary school? That's 10, 20, 30. It actually goes in there evenly.
Yeah, I used to race this girl in 4th grade named CJ, and we would always run to the front of the class trying to beat each other, and it was done in like 30 seconds or less, like a whole paper.
So since no one is there and I don't want it to go in evenly, fine.
Did you change it?
I put a 1 at the end.
R1.
No.
Yes.
Oh wait, you want us to keep going? Like this?
No, I want you to write the fraction. 1/3. No.
Yeah. I can draw the little line on top, so you raise the point. It was gonna be good.
No. 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 What do you mean would have? Listen to what's happening. Everyone's having a tantrum anyway.
We even raced for the board.
Do you remember how?
152,994.
I think we should like.
No. Tomorrow, though.
Can it really?
How many times does 3 go into 4? 1 times 3 is 3. Subtract it to get a 1. Drop it. It's a little hot.
Wait, did anyone else bring that like guesstimate way?
Oh my god, I did it right.
There are different mental math tricks for it, but
No, this one was not.
okay. 16 divided by 3 goes in there 5 times. Multiply, subtract 1, drop it a little hot. 3 by 3 is 9, subtract. Drop it a little hot. Nine by 3 is 27. Subtract. You get a 2. Drop it. It's a little hot. 28 divided by 3 is also 9. 9 by 3 is 27. Subtract. Drop it. It's a little hot. And get 4, and then 4 by that is... What happens when I say screw you, Paul? And I put that 1 at the end. Okay. Don't write R1. And 1/3, right? 1 out of 3. The reason I bring this up is because tomorrow we review with polynomials. Oh, we got to know long division too. We will do synthetic, but we have to know long division too because synthetic only works with linear factors.